What the hell got into that damn thing? Attacking a carriage mid-air?
In 2022, I made a gaming benchmark video between Windows and Linux on my desktop PC. That was a full AMD setup. Today, I'm back with a non-AMD setup, a laptop to be precise. A Dell G15 5520 model that comes with a 12th Gen i7 Intel CPU and an RTX 3060 Nvidia GPU. I'll get back to the exact specs and put them on the screen. But first, I need to tell you that a couple of things will be different in this video from the previous one. First, this time, there are only 9 games and they all have ray tracing, as it has become a controversial topic lately. I personally don't find it worth sacrificing the frame rate for a marginal increase in image quality. Plus, it's one of the Achilles heels of Linux, so I wanted to focus the benchmark on it. Second, there won't be any upscalers involved in any of the tests. Therefore, no 4K benchmarks since this is a laptop with only 6GB of VRAM. Even 1440p is missing in some of the games because they either run at single-digit FPS or did not run at all. Alright, with this out of the way, let's get back to the test setup. I'm putting the specs on the screen so I can keep the video shorter. I've freshly installed both operating systems and tweaked them specifically for gaming. I tried my best to keep things as any gamer would want to optimize their system. Tweaking Windows 11 was much harder. You can see the steps I have taken on the screen. The Linux side was noticeably quicker to get ready for gaming. I simply synced Manjaro with Arch repos because I believe they have the most up-to-date drivers and the software. One last thing before I begin. On Windows, our Nvidia RTX 3060 GPU has 2 nice features. Shared memory allows the GPU to utilize some of the system RAM, which is extremely necessary for a laptop with only 6GB of VRAM. And the boost feature simply lets it draw more power than normal for a short time, as long as both the GPU and the CPU are cool enough. These 2 nice features are absent on Linux, and that gives Windows an artificial advantage over Linux if the benchmark is shorter than 1 minute until the GPU heats up and the boost is disabled. I'll talk more about that at the end of the video after the benchmarks. Let's get to the benchmarks. Cyberpunk has dropped to single digits at 1440p, so we only have 1080p results. On Windows side, there are playable frame rates at 1080p with everything set to ultra without any RT. 1% lows being higher than 50 makes the frame rate very stable. When ray tracing is enabled, it dives into the sub 30 area, clearly begging for an upscaler. On Linux side, when ray tracing is disabled, there's a 15% drop in performance, but 1% lows take a 41% hit, making the game much more stuttery. When ray tracing is enabled, things only get worse, and the performance gap increases to 23%. In our second benchmark, Callisto Protocol, we can see the negative effects of having lower VRAM more clearly. At 1440p on Windows 11, Ultra settings benchmark at just under 40 FPS with occasional dips to 13.7 FPS. This extremely low 1% is due to constant VRAM bottlenecks. The performance takes a stable 20% hit when ray tracing is enabled, and the 1% lows fall as low as 9 FPS. Even at these single-digit frame rates, the game only stutters, never freezing. On the Linux side, however, in addition to a 20% drop in the average numbers, the 1% lows take a much steeper dip to 1 FPS. When ray tracing is enabled, the averages are lowered by another 26% and the 1% lows stay at 1. However, these numbers don't tell the worst part of the story. I actually had to try more than 5 times to even complete the benchmark on Linux because it kept crashing due to insufficient VRAM. At 1080p, Windows gets some breathing room and averages rise to 58.4 and 48.2 for non-ray tracing and ray tracing scenarios respectively. 1% lows are at an acceptable rate for a laptop, considering it was constantly swapping data between VRAM and the system RAM. Linux, on the other hand, did not have the same breathing room, and its 1% lows stayed at 1 FPS because it had to stream the textures from the SSD at all times. Our next game on the list is Hogwarts Legacy. It doesn't come with a built-in benchmark tool, so I measured the intro cinematic, which is longer than 6 minutes. Since it's longer than 1 minute and also puts a constant load on the CPU, Nvidia's power boost eventually turns itself off, and the performance between both operating systems gets closer. Considering the constant VRAM problems, I can say Linux has done well here by losing only 13% and 10% performance in non-ray tracing and ray tracing sessions respectively. Guardians of the Galaxy refused to run until I used the Proton trick to hide the Nvidia GPU. It ran only when it was convinced that my GPU was an RX 6700 XT. Then, the performance basically suffered for RT-enabled cases. For non-RT measurements, I was able to get a playable frame rate, but having both 1440p and 1080p results the same indicates something has gone terribly wrong here. When I enabled ray tracing, the Linux side fared roughly 1/3 of the Windows results. This game is a good example of how important per-game optimizations can be for Linux. Let's get to a more optimistic result. Hellblade, Senua Saga from Microsoft Studios come with Unreal Engine software Lumen ray tracing. So, it doesn't require any special hardware for ray tracing, but it is so heavy, I don't think it is possible to play it without any form of upscaling on most of the hardware on the planet. A sad reality about where the gaming industry is rapidly going. For the sake of benchmarking, I captured the intro cinematic of the game again. Since it takes more than 5 minutes, the results represent the actual gameplay more than a shorter benchmark because the boost feature turns itself off due to increased temperatures. Linux is as close to its Windows counterpart as 2 FPS here, an 8% sacrifice, including the margin of error. We started discovering different variants of ray tracing, so let's continue with Metro Exodus Enhanced Edition. It uses dedicated ray tracing hardware, but as a change, it doesn't use any non-ray traced lighting methods, so the entire game relies on the ray tracing capabilities of the GPU. I measured a cinematic sequence from the beginning of the game, where Artyom runs into a bunch of mutants in the metro and is then saved by his friends. Since the game is relatively old, it doesn't torture the VRAM too heavily, therefore enabling a playable frame rate on both systems with acceptable 1% loss. Linux loses a constant 12% on both resolutions. Another software-enabled Lumen game, Robocop Rogue City, suffers from the lack of VRAM. I captured a 2-minute 30-second cinematic part from the early moments of the game. High-quality Lumen reflections bring both systems to their knees at 1440p. At 1080p, Windows is barely at 40 FPS, whereas Linux settles at 30, resulting in a 25% performance loss. However, the main discomfort here is the constant stutters and the random freezes when the game needs to clear VRAM. And that happened more than 20 times in this 2-minute 30-second sequence. I also tried to play this game without any benchmarking. I disabled Lumen and set the textures to low, but it kept filling the VRAM and eventually crashing the game after roughly an hour of gameplay. Another positive title on the list. I don't know how Valve is doing it, but The Witcher 3 gives the best impression for modern Linux gaming with Nvidia GPUs so far. Rasterization-based gameplay is within the 1 to 2 FPS margin between both systems, and ray tracing on Linux is basically on par with Windows as long as the VRAM is not bottlenecked. At 1440p though, unfortunately, the VRAM curse strikes again and the difference jumps to 21%. Our final game on the list is Crysis Remastered. I was always a big fan of how Crytek implemented the first fully featured ray tracing without requiring dedicated hardware, and this game is one of them. It normally runs on DirectX 11, and this is another reason why it is special on the list. Because DirectX 11 under Linux uses a different translation layer than DirectX 12. The ray tracing part of the game is written with Vulkan though, so it becomes a DirectX 11 plus Vulkan hybrid when ray tracing is enabled. The results are as expected here. Linux is 5 to 9% behind Windows with a stable performance. The only disturbing moment was when the VRAM was full at 1440p with ray tracing enabled. Here are all the benchmarks for 1080p in one graph. Linux is behind 18.7% on average when ray tracing is disabled, and 22.5% when enabled. 1% lows are much worse on Linux, and I don't think I can recommend playing like this. An ideal move would be to set the textures to low as possible, but this would only delay the inevitable, as almost all of these titles fill up the VRAM, leaving the cleanup to the Nvidia driver, which does nothing about it on Linux. At 1440p, the results are nearly the same. Linux is losing by 20.2% at rasterization and 23.7% when ray tracing is enabled. At 1440p, the VRAM fills even more quickly and the problems hinder the gameplay quality even more. So, here are my personal findings. First, laptops are really hard to benchmark, and the results are barely reliable. On desktops, each component can take care of its own thermal problems with independent fans and much more ventilation room inside the case. Laptops share their fans and cooling pipes, and they have very limited ventilation space. Second, hardware features like memory sharing and boost try to mitigate these performance problems, but they're absent on the Linux side. This is not a problem of bad or non-working drivers. These features have been reported as not working repeatedly since 2015, and Nvidia deliberately dodges these reports. leaving them unanswered. At this point, I believe I now have enough reason to say this is not a driver quality or performance issue. It is a deliberate setback. I'm aware that Nvidia has made some welcome progress lately, and I genuinely hope such inconveniences will also be resolved quickly in the near future. 3. Linux has an indirect advantage here. On Windows side, Windows tends to use more CPU, therefore making the CPU go higher temps much quicker, disabling the boost. On Linux, this is not the case. Linux by its nature uses less CPU cores and less CPU cycles. It results in less heat produced. So this helps with the Linux performance on the laptops. In addition to that, the translation layer of Proton, which converts all the DirectX calls into Vulkan calls, utilizes multi-core structure much better than DirectX. This also lowers the CPU usage, and Linux gets away by using lower CPU than Windows, so this enables the GPU be able to draw more power under the load. 4. What is my preferred OS then? I still have my full AMD desktop PC, and as a gamer who almost never plays competitive games, I prefer Linux on my desktop for all the games I play. For this laptop, on the other hand, I prefer Linux for all the titles up to DirectX 11 and switch to Windows for newer DirectX 12 titles. However, I'm fairly optimistic that this will change in the future. Thanks for watching this far. Please feel free to ask any questions you have and let me know how I could improve myself for the next video. And as always, happy gaming!